So in order for there to be a relationship that exists, think of relationships in general. When a relationship exists, how many should there be? 2, right? In order for a relationship to exist, guys, in order for a relationship to exist, there has to be at least 2 involved. Otherwise, there isn't a relationship. Okay, it's the same idea when you're talking about angles. In order for there to be a relationship, you have to have at least 2 angles that you're talking about. Okay, so the relationship that exists between those 2 angles or 3 angles, that's what they mean by a relationship. So you guys already know angle classifications. You know what an obtuse angle is. What's an obtuse angle? Greater than 90, but less than 180. Okay, you know what a straight angle is. What's a straight angle? 180 degrees, exactly. Good. A right angle? 90 degrees, exactly. And an acute angle? More than 0, less than 90. Good. So you guys know how to classify angles. So now we're going to talk about how to create relationships among angles. So the first relationship, and the one that we talk about and focus on the most in this situation, is vertical. It's probably the most difficult one, even though in reality it's actually a very, very easy angle relationship to understand. But vertical angles, they are opposite angles. And more importantly, they're congruent. It's pink. What do I mean by congruent? Who can tell me, what does congruent mean? What's another word for congruent? Emiliano? No, that's not what congruent means. Demi? Equal. Equal. Okay, now what you're thinking, Emiliano, you're thinking adjacent. That's side to side. Okay, but congruent means that they are equal. They are the exact same size in measure. Okay, so I'm going to draw an example down here later to show you some examples of vertical. But go ahead and just skip a couple. So we'll have an example. I want you to skip a couple lines. Then we're going to go and talk about adjacent. Just like Emiliana was saying, side by side. So adjacent angles, they are side by side angles. They share a common ray and vertex. Okay, so they are side by side. They are side by side angles. So we're going to go ahead and create just a little bit below here. I'm going to create this diagram here. So I've got a set of intersecting lines. They can continue going in both directions forever and ever. And we'll label this one A, this is going to be X, this is going to be R, and this is M. So if I'm talking about vertical angles, and I'm looking at angle A, what angle is directly opposite of it? That would also be the same exact size as it. Angle what? R. Good. Angle R is directly across. So what you're basically doing is you're able to go through the vertex, and you're supposed to be able to connect them with a straight line through the vertex. If you have to go to the vertex and then curve to get to the next angle, then it's not a vertical angle measurement to it. It has to be a straight connection through the vertex to make it a vertical angle. So angle A, let's go back up to where we talked about vertical. Angle A and angle R are considered to be vertical angles. What about, here, we'll do another color. We'll do blue. What about angle X? What is its vertical relationship? M. Again, if I start at X and I go to the vertex and continue straight through the vertex, it's going to end up at angle M. So angle M and angle X are considered to be vertical angles. And you can say angle X, angle M, it doesn't matter. Those are our examples of vertical angles. Now, adjacent. Again, adjacent means it's side by side. So if you kind of think of it like a neighborhood, if you live in a neighborhood, you have one person who lives directly across from you. But how many people live next door to you? 2. You have somebody who lives next door to you on your right side and someone who lives next door to you on your left side, unless you live like on a corner. But so to speak, if you're in the center and you have somebody directly across from you, that's your vertical neighbor. When you have 2 people living on either side of you, those are your adjacent neighbors. So it's the same thing with angles. Angles have 2 adjacent relationship pairs. So angle A is adjacent to angle X. So angle A and angle X happen to be adjacent angles. Angle X is also adjacent to angle R. Angle R is also adjacent to angle M. And then angle M is also adjacent to angle A. I have to write it over to the side. So those are your adjacent pairings that you can create. Let's take a look at another set. All right, given the following, I want you to go ahead and list off to me my vertical angles. We'll start there. Who can tell me which angles happen to be vertical angles to each other? Meaning they are directly opposite of each other. They are the same exact measurement. Omar. Huh? F and R? So F and R. My only problem here, guys, with vertical angles, they can't be adjacent. If they are vertical, they cannot be adjacent. So they can't be next door to each other. So which one would it have to be then, Destiny? X and R. X and R, and they happen to be the only, they're the only set for our vertical angles, because F is not vertical to M, it's not vertical to B, because it can't be a direct opposite to it, can it? Nor are they congruent in measure. So the only angle relationship that's vertical is angle X and angle R. That's it. Now, let's go into our adjacent angles. Our adjacent angle measurements. Let's start with angle X. What is angle X adjacent to? M. Good. So angle X and angle M. We can start at X. We can go to M. So now let's continue following the wheel. What's angle M also adjacent to? B. Okay, what is angle B also adjacent to? R. What is angle R also adjacent to? Richard, this is not a sound out the letter kind of class, okay? And then angle F is also adjacent to? Oh, what? You don't want to sound that one out, Richard? All right. Remember, you are being videoed. Uh-huh. All right. Knowing these relationships, if we know that they're vertical and that they're congruent, we can actually solve for missing angle measurements when it's dealing with a vertical angle relationship. I'm going to go ahead and switch the sides. Okay, go on to page 33. So if I have the following setup, we'll start off with something easy. If this is 2x and this is 70, and I want to solve for x, these are vertical angles. Because they're vertical angles, then I know that I can set these equal to each other. Because they're vertical angles, I can say that 2x is equal to 70, and then I can solve it. Because again, vertical angles mean they're equal in measure. So 2x has the exact same measurement as 70 degrees. And I'll have to put my little degree symbol here. So all I have to do is set up an equation that says 2x equals 70 and then solve. What do I have to do to solve this, Brent? Very good. We're going to divide by 2 on each side, and what will x equal? 35. Hashtag shut up. All right. Let's take a look at another problem. So that was an easier one. Let's say that we've got something like this. If we've got 3x minus 1, stop. And then we'll say we'll say 155 degrees. Okay? So now, again, they're vertical angles. They are directly opposite from each other. So we would set this up as 3x minus 1 is equal to 155, and then we would solve. Who can raise their hand, tell me what is the first step that we would need to do to solve this problem? Emiliano? Very good. You're going to add 1 to both sides. We're going to add 1 to both sides. That's going to give us 3x is now equal to 156. Then what? Salmon. Good. You're going to divide by 3 on both sides. And if we do 156 divided by 3, what does the measurement of x equal? 52. Good. So we get 52 there. Okay, now, these are not the only kind of angle relationships that we have, vertical and adjacent. We don't have those. There's also complementary and supplementary. So let's take a look. Complementary and supplementary are probably the most mistaken relationships. People commonly mistake them. They'll accidentally mistake the complementaries definition for supplementary and vice versa. You want to make sure that you're careful about that. With complementary, complementary is two or more angles with a sum. That's important. A sum of 90 degrees. That means you're taking one angle and adding it with another angle, and that's going to equal 90. So in a complementary relationship, can either one of those angles equal 90 degrees? No, because if one of those angles is a right angle, then you can't have a complementary relationship with another angle, because then your sum would be greater than 90 degrees. So complementary essentially means you have two acute angles. In a complementary relationship, you must have two acute angles. And those two acute angles have to have a sum of 90 degrees. Supplementary. In a supplementary angle relationship, you have two or more angles with a sum of 180 degrees. 180 degrees. 180. So you could have a whole bunch of acute angles that would add up to 180. You might have two right angles, that adds up to 180. You might have one acute and one obtuse angle that have a sum of 180. There's different ways that you could pair it. But at least with complementary, you know you can only have acute angles. You can't have right angles. You can't have obtuse for it to be complementary. Okay. Now, one of the ways that some of my students in the past have come up with a mechanism to remember complementary versus supplementary, some of them said, well, hey, alphabetically, C comes before S, and 90 numerically comes before 180. That's one way they thought of it. Another one that somebody came up with, they thought of complementary. If I give you a compliment by saying you're always right, I'm paying you a compliment by saying you're always right. So complementary forms right angles. So that was one thing that a student came up with a couple years ago. All right. Now, with this, if we have, I want you to identify complementary, supplementary, or neither. So if I give you go ahead and identify if they're complementary, supplementary, or neither, because it doesn't always have to be an angle relationship. After notes are done. All right, who can tell me? Number 1, is it complementary, supplementary, or neither? Christopher. It's neither, right? Neither. Okay, if you take 90 degrees and you add 89 degrees, it's going to give you 179 degrees. So doesn't match any one of those relationships. What about problem number 2? Complementary, supplementary, or neither? Ethan. Complementary. Okay, so this is going to be complementary. When you add those together, if you take 26 and you add it with 64, it's going to be equal to 90 degrees. That is complementary. And then the last one, number 13, complementary, supplementary, or neither? Omar? Jocelyn? Supplementary. Again, if you just add them together, 148 plus 32, you're going to get 180 degrees. Okay? And then you still have the same idea that you can go ahead and solve for angle measurements based off of the relationship that you see there. Okay? So, page 34. Right off the bat, what relationship do I know exists here? Complementary, right? I know that this is a complementary angle set because of the fact that it's forming a right angle. It forms a right angle when I have these two angles paired together. So I know complementary has to be equal to 90 degrees, and it's the sum that is equal to 90 degrees. So again, I'm adding these two angles together to equal 90 degrees. So my relationship, or my equation, is going to be x plus 68 equals 90. That's different than the vertical angles. Vertical angles, you set them equal to each other. Complementary or supplementary, you're creating an addition equation and setting it equal to either 90 or 180. What would we do to solve here? Salomon? Very good. Well, you don't have to divide by the 1 because that's not going to change anything. Remember, if there's a positive 1 coefficient, you don't have to worry about doing anything. It's already simplified and isolated. So this was just a one-step equation. You just have to go ahead and subtract the 68 from both sides, and you would get that x is equal to 22 degrees. Yes. Remember, I teach you how to do the whole process, right? So sometimes the question might state, what would the equation look like? So if this is a short response problem, you would have to correctly set it up as an equation and then show the process of solving in order to be able to get full credit. Hint, hint, that's something that's going to be like it on your test. Okay? And in fact, there's several questions, even some multiple choice questions, that are merely asking which one is the correct setup of the equations and which one is correctly solved. So you need to make sure you know how to do both. Still using notes at the end of class for when notes are done, then you may go. Okay? All right, if we have 2x for one angle measurement and 36 for the other angle measurement, what kind of relationship is this being created? Supplementary. So automatically, since this is supplementary, I know that I have to set it equal to 180. So the equation, again, you're adding both angles together and setting it equal to 180. The equation is going to be 2x plus 36 is equal to 180 degrees. Then we solve. What do we do first? Omar? Minus 36 degrees. Good. So we'll subtract 36 degrees first. That leaves us with 2x is now equal to 144. And then what's our last step? Divide by 2. And we'll get x is then equal to 72. I want you guys to solve for x and y on your own. Figure out what angle relationships you might have to do first to help solve for another angle relationship.
Oh, wait.
All right, so anybody want to tell me what they got for x? Vincent? 30. What about for y? Jimmy? 30. Okay, so in a problem like this, though, based off of the setup, which variable do you think you'd need to solve for first?
Oh,
Y. Why? Why would you need to solve for y? Okay. So so you used y first. Does it really matter which one you solve for first? There's two different relationships you can see, right? What relationship do you see for the x? What relationship is there? If you're focusing on the x, what relationship can you use? Complementary, supplementary, or vertical? Supplementary. Because it's supplementary with 120. What relationship can you use for the y? Complementary, supplementary, or vertical? Vertical, because it's vertical to the 120. Okay, so doesn't really matter which one you would do first in this case. You could do either or. Okay, so let's go ahead. We'll split this up separately. Let's go ahead and do supplementary first. So we'll set up the supplementary relationship that we see. We've got 2x plus the 120 is going to be equal to 180. That's one relationship that we can create. We would subtract 120 from both sides. That would give us 2x is then equal to 60. We would then go ahead and divide both sides by 2, and we would get that x is going to be equal to 30. Then we can set up our vertical angle pair, which means that they are equal to each other. So we have 3y plus 30 is equal to 120. 3y plus 30 is equal to 120. You would subtract 30 from both sides. That would give you 3y is now equal to 90. And then you would divide both sides by 3. And that would give you y is equal to 30. All right, any questions? Okay, you do have a worksheet that you're going to be completing today. And this is great. I know we didn't get a chance to work into our equations booklet, but this was actually really good equation practice anyway. Make sure that you're using that equation booklet as well if you need to refer back to any of your notes on how to solve.